Smooth infinitesimal analysis is a modern reformulation of the calculus in terms of infinitesimals, based on the ideas of F. W. Lavera and employing the methods of category theory. It views all functions as being continuous and incapable of being expressed in terms of discrete entities. As a theory, it is a subset of synthetic differential geometry. The nil-square or nilpotent infinitesimals are numbers epsilon where epsilon squared equals 0 is true, but epsilon equals 0 need not be true at the same time. This approach departs from the classical logic used in conventional mathematics by denying the law of the excluded middle, e.g., not does not imply A equals B. In particular, in a theory of smooth infinitesimal analysis one can prove for all infinitesimals epsilon not, yet it is provably false that all infinitesimals are equal to 0. One can see that the law of excluded middle cannot hold from the following basic theorem. Every function whose domain is R, the real numbers, is continuous and infinitely differentiable. Despite this fact, one could attempt to define a discontinuous function f by specifying that f equals 1 for x equals 0, and f equals 0 for ex 0. If the law of the excluded middle held, then this would be a fully defined, discontinuous function. However, there are plenty of x, namely the infinitesimals, such that neither x equals 0 nor x 0 holds. So the function is not defined on the real numbers. In typical models of smooth infinitesimal analysis, the infinitesimals are not invertible, and therefore the theory does not contain infinite numbers. However, there are also models that include invertible infinitesimals. Other mathematical systems exist which include infinitesimals, including non-standard analysis and the surreal numbers. Smooth infinitesimal analysis is like non-standard analysis in that it is meant to serve as a foundation for analysis, and the infinitesimal quantities do not have concrete sizes. However, smooth infinitesimal analysis differs from non-standard analysis in its use of non-classical logic, and in lacking the transfer principle. Some theorems of standard and non-standard analysis are false in smooth infinitesimal analysis, including the intermediate value theorem and the Banach-Tarski paradox. Intuitively, smooth infinitesimal analysis can be interpreted as describing a world in which lines are made out of infinitesimally small segments, not out of points. These segments can be thought of as being long enough to have a definite direction, but not long enough to be curved. The construction of discontinuous functions fails because a function is identified with a curve, and the curve cannot be constructed pointwise. We can imagine the intermediate value theorem's failure as resulting from the ability of an infinitesimal segment to straddle a line. Similarly, the Banach-Tarski paradox fails because a volume cannot be taken apart into points.